Today we're going to learn how to solve exponential equations, and it's a good follow-up to what we have been doing with the properties of exponents, and it's not very hard, especially with the calculator in your hands. So we're going to start with a basic problem like solving this equation. 5 to the x power equals 125. Now, this is much easier than what it looks like. All we need to do is make sure that both sides have the same base. The left side already has 5 as a base. It's 5 to the x. With the calculator in your hands, if you're not sure, couldn't we figure out what 5 to what power makes 125? All right, it's pretty easy. If you try it on your calculator, I think you find out that it's 5 to the third power. Okay, if we cube 5 times 5 times 5, we get 125. And there's a property called the one-to-one property that says if these two bases are the same, then I can drop them and set the exponents equal to each other. So basically, this problem is done. X equals 3. Very simple problem once you get them written with the same bases. Now sometimes after we drop the bases, we'll have to do a little bit of algebra, but nothing hard. Let's do one of those. Let's say that we had 12 to the 2x plus 3 power equals 144. Well, I told you our goal is to get this so that I have both sides with the same base. The left side already has it. What's the right side going to become? 12 to what power? To the second power. Good. And now that we have the same base on both sides, I can set the exponents equal to each other. So we've got a little bit of algebra to do here, but nothing very hard. 2x plus 3 equals 2. And we just do our basic algebra to solve this thing for x. 2x equals -1. Divide both sides by 2. So x equals -1/2. So once you get the bases the same, we see that it's pretty easy. All right? All right. I'm going to give you one to try on your own. I'm going to pause the video for a second and let you try this one on your own. If you're watching the video, pause the video and try this one on your own and see if you get it right. All right, let's see how you did on this problem. I should have written my next line as 7 to the 3x minus 2 equals 7 to the second. And now that I've got the same bases, I can set the exponents equal to each other. 3x minus 2 equals 2, and we do our algebra to solve it. Add 2 to both sides. 3x equals 4. Divide both sides by 3. So x equals 4/3. So we've got the idea, but there's a couple little, as always, a couple little situations that I want to walk you through that you're going to run into. Here's the first one, a problem like this. 25 to the x minus 1 equals 5. Now the first thing you notice is that the 5 doesn't have a power. Well, if there's no power, then it's 5 to the first. And on the left side, I think it's obvious that 25 is 5 squared, right? But it's 5 squared all to the x minus 1 power, which means we need to use one of those rules of exponents that says when I have a power to a power, I multiply the exponents, but I have to do distributive property. So that will be 5 to the 2x minus 2 power now, after I multiply those two, equals 5 to the first. And now we're ready to drop the 5's and solve it. So I can set my exponents equal to each other. 2x minus 2 equals 1. Add 2. Add 2. 2x equals 3. Divide both sides by 2. X equals 3/2. Now, just a couple other, I guess we would call it hints or tricks that you would need in some special situations. If I had this problem, 36 to the x equals 1/6. Well, we really do know how to deal with this. You just may have forgotten what we learned about negative exponents. Do you remember? I'm going to make up a problem here. If I had 5 to the negative 2, that's the same thing as 1 over 5 squared. Just move it to the bottom. So what we can do is we can take it from this form back to this form. So on this right-hand side, 1/6 is the same thing as 6 to the negative 1 power. And now we're ready to move forward. The left side is 6 squared to the x, which when I do power to a power, I have 6 to the 2x. Just multiply the powers, equals 6 to the negative 1. Shouldn't it be easy from there? Okay, so I'm just going to say finish normal on this problem. I want to keep the video at a decent length and get to our last situation. You know what we do, we just set 2x equal to negative 1 to finish it up. Last special situation. Remember to have your notes close by, or have this video close by when you're doing your homework so you know what's going on. 4 to the x equals 8. Now this one's a little bit different because if I look at this 4 and I think of my powers of 4, 4 to the first is 4. What's 4 to the second? It's 16. I cannot raise 4 to a power and get 8. So what I have to do here is make a note to yourself. Change both bases. And instead of thinking of a power of 4, let's think of a power of 2. Would you agree that 4 is 2 squared? And 8 is 2 cubed? So on this problem, this doesn't happen as often in your homework, but it does happen, I think, a couple times. We need to change both bases like I did. So I made them both a power of 2. So this would be 2 to the 2x equals 2 to the third. And now I could drop my 2's and solve it. 2x equals 3. Divide both sides by 2. X equals 3/2. And we will stop there for today.